Good morning, one and all. Myself, Dr. Syed Gauspiroz, working as an associate professor in M. Reddy Memorial College of Pharmacy. Here, I explain a brief introduction regarding pharmaceutical emulsion. Emulsions are biphasic liquid dosage form of medicament in which two immiscible liquids added, that is oil phase and water phase. These both are immiscible with each other. For miscibility purpose, we are adding emulsifying agent. So the emulsifying agent like acacia, tragacanth or protein based we are adding. An emulsion is a biphasic dosage form in which two immiscible liquid, one which is dispersed as finite globules, in the other the particle size globules are 0.25 to 25 micrometers particle size. So here the emulsions comes under the coarse dispersions. The pharmaceutical dispersion systems are classified into three types, that is molecular dispersion, colloidal dispersions and coarse dispersions. Here this is coarse dispersions. The examples of coarse dispersions are acacia. Examples of coarse dispersions are emulsions and suspensions. So the classification of emulsions can be classified into four types: oil in water type, water in oil type, multiple emulsions and micro emulsion system. So here oil in water type of system, oil is an discontinuous phase, water is continuous phase. That is, the small amount of oil droplets are dispersed in water is known as oil in water type of emulsion. Next, water in oil type of emulsion, that is, the small water droplets are dispersed in oil, is known as the water in oil type of emulsion. And multiple emulsion, here the multiple emulsions consists of the two types: water in oil by water and oil in water by oil. So why it is called as multiple emulsions means, here two types of emulsions will be consists. So by this purpose it is called as the multiple emulsions. So here, based upon the size of liquid droplets, if particle size is 0.2 to 50 mm, it is called as the macromolecules. If particle size is 0.01 to 0.2 mm, microemulsions. If particle size is 50 to 1000 nanometers, that is called as the nano emulsions. So based upon the emulsions, the small differences and the importance of oil in water, water in oil. Here the slide is consists of the comparison of oil in water and water in oil. Water is the dispersion medium and oil is the dispersed phase, is known as the oil in water type of emulsion, and oil is the dispersion medium and water is the dispersed phase, is known as the water in oil type of emulsion. Water soluble drugs are more quickly released from oil in water type of emulsions. Here oil soluble drugs are more quickly released from water in oil type of emulsions. The oil in water type consists of, they are preferred for formulation meant for internal use, as bitter taste of oils can be masked. That is the main scenario to prepare the emulsions for oral. They are preferred for formulations meant for external use like creams and some of the gels. The creams, that is vanishing cream and cold cream. And they are non-greasy and removable from the skin surface. In water in oil, they are the greasy in nature and not water washable. We are adding of detergents or surfactants to washable will be occurs. So here they are used externally to provide cooling effect. Here they are used externally to prevent evaporation of moisture from the surface of skin. Oil in water type of emulsions give positive conductivity test as water is the external phase, which is good conductor of electricity. Here water in oil emulsions go not give a positive conductivity test as oil is an external phase which is poor conductor of electricity. So the main applications of emulsions, that is emulsions for oral route and emulsions for rectal route and emulsions for topical administrations of oils and oil soluble drugs. So some of the drugs we cannot be take easily because of that is consists of the unacceptable order. So by this purpose, we are adding emulsifying agent to mask the odor and mask the taste. So this type of emulsions, that is liquid paraffin emulsions for oral administration. Next, rectal and topical administrations, some of the oils and oil soluble drugs. Next, the another applications is the unpleasant taste or odor can be masked by the emulsification. The absorption and penetration of medicament are enhanced by the emulsification. Emulsions also useful for the intramuscular injections of water soluble drugs or vaccines to provide slow release. The use of sterile stable IV emulsions containing fats, carbohydrates, vitamins as potential nutrients. Next, formulation of emulsion. There are mainly 5 ingredients involved in the formulation of emulsion, that is selection of emulsifying agent. The main important of selection of emulsifying agent, an emulsifying agent is an material that enhance the stability of an emulsion, that is prevention of coagulants and reducing the creaming. So if presence of coagulants and presence of creaming, that is determined as the unstable emulsion. The ideal emulsifying agent is colorless, odorless, tasteless, non-toxic, non-irritant, and able to produce stable emulsions at low concentrations. Here some of the examples of emulsifying agents like carbohydrate material, that is acacia tragacanth, agar, pectin. These are the oil in water type of emulsions we are used to prepare emulsifying agents. Next, protein substances like gelatin, egg yolk, casein. These are also we are used for the preparation of oil in water type of emulsion for selection of emulsifying agent. Next, high molecular weight alcohols like stearyl alcohol, cetyl alcohol, glyceryl monostearate, oil in water type of emulsion, and cholesterol we are used as the water in oil type of emulsion. And the second ingredient is the selection of oil phase. Nearly equal density of solvent like water, we are used to take the oil's density. That is, the density of water is 0.9961. Nearly equal density of water type of oil, we are used to select the preparation of emulsion, because of if density differences are more easily producing the creaming and coagulants. Next, water, we are used to purified distilled water for the preparation of emulsion. Next, the emulsions, the mixture of oil and water, they produce the rancidity. So that is instability. So by this purpose, we are adding some antioxidants and preservatives to make up the emulsions. And some of the wetting agents also, like anionic, cationic, and finely divided solids also, we are used to prepare the emulsions. Next, after preparation, we check our prepared emulsion is consists of oil in water type or water in oil type. So there are some tests used to perform to determine the given emulsions are consists of these types. The mainly dilution test, stain test, conductivity measurement test, fluoroscan test, and another one is the cobalt chloride test. Also, we are used to check the given emulsion is oil in water type or water in oil type of emulsion. So, first dilution test. The prepared emulsion, small amount of prepared emulsion added in water. If emulsions soluble in water, that is called as the oil in water type of emulsion. So by this purpose, the heading will be consists of miscibility test. If prepared emulsion immiscible in water, that is called as the water in oil type of emulsion. The second test go to stain test, that is dye solubility test. Here we are using water soluble dye. We are using water soluble dye like methylene blue. When water soluble dye is added in prepared emulsions, so the external phase is appears as the blue color, that is oil in water type of emulsion. If internal phase is appears like blue color, that is water in oil type of emulsion. Because of here we are selecting water soluble dye. So by this purpose, external phase is appears blue color. Next, conductivity measurement test. Here the conductivity, that is based upon the electricity generation. We determine the oil in water type or water in oil type also. For example, the prepared emulsion transferred into the beaker, then immersion of two electrodes, that is positive negative electrodes, it is connected with one small bulb. If bulb glows, the prepared emulsion is oil in water type of emulsion, because of water is the good conductivity of electricity. If bulb not blows, that is consists of water in oil type of emulsion because of oil not produce the electricity. Next, fluorescent test. Here, the test is also called as the light scattering test or microscopic test. One drop of the prepared emulsion is added to glass slide and check electron microscope. If external phase is appears the VGR like colors, that is water in oil type of emulsion. If external phase is appears of the dark background, that is oil in water type of emulsion. So check previous three is the oil in water type of emulsion for the positive result, but fluorescence is the water in oil type for positive result. Next, cobalt chloride test. First, filter paper is immersed in the cobalt chloride solution. The filter paper is changes to blue color. The blue color containing filter paper is immersed in the prepared emulsion. If filter paper changes to color blue to pink color, that is consists of oil in water type of emulsion. If color change not occurs, that is water in oil type of emulsion. So we are selecting the emulsification based upon the HLB scale, that is hydrophilic lipophilic balance. The Griffin is identified or give the hydrophilic lipophilic balance scale. It is consists of the based upon the surfactants type, hydrophilic head and lipophilic tail. The scale is consists of 1 to 20, represents the relative proportion of lipophilic and hydrophilic parts of the molecule. The high number like 8 to 18 indicates a hydrophilic molecule and produce oil in water type, and low numbers like 3 to 6 indicates a lipophilic molecule and produce water in oil type of emulsion. Oils and waxy materials have required HLB number, which helps selection of appropriate emulsifying agent. Liquid paraffin, for example, has required HLB value of 4 to obtain water in oil type of emulsion and 10.5 for oil in water type of emulsion. So there are different methods to determine the HLB. That is mainly three methods to determine the HLB. That is HLB equal algebraic sum of hydrophilic portion plus the algebraic sum of lipophilic portion minus 7. And the second method is HLB equal epoxide groups plus polychain groups by 5. And third method is HLB equal 20 into 1 minus saponification number by acid number. So the third method, already we did the experiment in physical pharmacy 1. That is, in that we are taken as the for saponification purpose, that is twin 80 plus alcoholic KOH for reflex condensation 70 degrees centigrade for 20 minutes. After 20 minutes, cool the substance and titrated with HCl solution. The color change will be occurs. So same procedure is repeated for the blank, that is without fatty agent like twin. The comparing the value, we are substituting the formula, that is B minus A into equivalent weight into weight taken we got the saponification number. That saponification number, we substitute the formula and note the acid value. We got the HLB. Based upon the HLB, if it is 16 or 9, we are determining as the solubilizing, that is oil in water type of emulsion. If HLB is consists of below 9, that is water in oil type of emulsion. That is the importance of HLB in preparations. So the HLB, some of the examples of emulsifying agent like diethylene glycol monostearate, the value is 4.7, sucrose diolate 7.1, and polyethylene for lauryl ether 9.5, sodium volate is 18.0, polyoxyethylene 100 stearate 18.8, potassium volate is 20. Next, coming to methods of preparation. So there are three methods to prepare the emulsions, like dry gum method, wet gum method, and bottle method. So this is here we are using trituration method for dry gum method. The composition is 4:2:1. That is 4 parts of oil, 2 parts of water, and 1 part of emulsifying agent. Here dry gum. The dry gum means first gum is mixed with the oil to form the smooth paste. Then after that we are adding the water. That is called as the dry gum method. In this method, oil is first triturated with gum with a little amount of water to form the primary emulsion. The trituration is continued till characteristics of clicking sound is heard and thick white cream is formed. Once the primary emulsion is formed, the remaining quantity of water is slowly added to form final emulsion. Here we are using some of the homogenizers and silver sun mixtures to use to prepare the emulsion. Next, wet gum method. As the name implies, in this method, first gum and water is triturated. Listen carefully. The dry gum, we are using oil and gum, but here wet gum, first we are triturating with gum with water, triturated together to form the mucilage. The required quantity of oil is then added gradually in small proportion with thorough trituration to form the primary emulsion. Once the primary emulsion has been formed, the remaining quantity of water is added to make the final emulsion. Next, stability. So here we are preparing the emulsion and check the identification of emulsion. And after that, we are determining how the emulsion is stable. An emulsion is said to be stable if it remains as such after its preparation, that is, dispersed globules are uniformly distributed throughout the dispersion medium during its storage. The emulsion should be chemically stable. There should not be any bacterial growth during its shelf life. That is shelf life. Oh, in that chemical kinetics, that is shelf life means the time taken by decline the rate of reaction 90% of its original volume. That is, if we are definition of the half-life, the time taken by the rate of reaction declines half of its original volume. If the emulsions are conscious of the improper dispersion, they said to be instability. They said to be instability. instability based upon the four parameters like cracking, flocculation, creaming, and phase inversion. So cracking means suppression, coagulants, that is two or more globules combine to form the large globule. The breakdown of the emulsion. Cracking means the separation of two layers of dispersed and continuous phase due to coagulance of dispersed phase globules, which difficult to redisperse during the shaking. Why the cracking will be occurs, that is by addition of emulsifying agent of opposite type, that is improper selection of emulsifying agent, by decomposition or precipitation of emulsifying agent, that is before we are adding the decomposing emulsifying agent we are adding means, or expired emulsifying we are adding means, they form the cracking. By addition of common solvents, like we are adding of some of the common solvents like co-solvent, glycerin or glycerol, alcohol. Next, by formation of microorganisms, that is for environmental focusing, for changes of temperature, or by creaming they will be forms. Next, coming to the flocculation. In flocculated state, the secondary interaction maintains the droplets are defined distance of separation. That is, application of shearing stress to the formulation will redisperse these droplets, form a homogeneous formulation. So that is flocculation. Next one is the creaming. The creaming may be defined as the upward movement of dispersed globules to form a thick layer the surface of emulsion. The creaming is temporary phase because it can be redistributed mild shaking or stirring to gain homogeneous emulsion. Next, phase inversion. The phase inversion, that is, if we are preparing oil in water type of emulsion, it will be changes to water in oil. They can be consists of the phase inversion. Due to the following reasons, phase inversion will be takes place. That is by addition of an electrolyte, by changing the phase volume ratio, by temperature change, by changing the emulsifying agent. So this is the preparation and evaluation of emulsion. The remaining topic, that is theories of emulsification, we continued on next class. Thank you. Any doubts regarding this topic? Okay, thank you. We will discuss the next topic like theories of emulsification next class.